Hello students, welcome to SS Power Education. Today I am going to start with the topic operations on sets. You can go and watch previous videos in part 1 to 6. Okay, now operations on sets. First is union of set. The union of set A and B denoted by the denotation A union B. It is read as A union B. Is the set of all those elements, each one of which is either in A or in B or in both A and B. Okay, so union of sets means you have to write all the elements of A and B like this. See, A is 2, 3, 4, 5 and B is 2, 4, 6, 8. The number should not be repeated. Okay, we have to write it like this: 2, 3, 4, 5, 6 and 8. All the elements are written like this. We have to write it same way. Now what are the properties of union sets? So union of sets is commutative, which is if A is union to B, then B is also union to A. Any two sets are union to each other. Union of sets is associative. Associative means for any three sets A, B and C, we have if A union B union C, then A is union B union C. Okay, if we are writing it in bracket, we can write it any which ways. Okay, now the third one is for any set A and B, we have A is a proper subset of A union B because A contains the elements of A union B. That is why A is a subset of A union B, and even B is a subset of A union B because B contains the element of A union B. Now A is a subset of B, then A union B is equals to B. Okay, why? Because A is a subset of B. A has some elements of B. Okay, therefore A is union to B and it is equal to B. Since A is subset of universal set, then A is union to universal set, which is equal to universal set. Okay, if any element, if any set is a subset of other set, then A union that subset will be equal to A union empty set is equals to A for every set A. If A is union to empty set, that means A is for every set. Now intersection of sets. The intersection of two sets A and B denoted by like this, ulta sign of A union B. Okay, this is ulta U, which is read as A intersection B. Now what is A intersection B? A intersection B means the set of all elements common to both A and B. We have to write only common elements, not all like in union. We have to write only the common elements like 2, 3, 5, 7, 9, 11, 13. B has 5, 9, 13, 17, 21. So A intersection B is this intersection, which is 5, 9 and 13. We have to write only the common elements. Okay, common numbers, not all. Okay, now disjoint sets. Two sets A and B are said to be disjoint if they have no element in common. So if both the sets does not have common elements, then it is known as disjoint sets. Okay, intersecting sets. So two sets are said to be in intersecting or overlapping or joint sets if they have at least one element in common. Okay, only one element is common, then also it is known as intersecting sets. Okay, now properties of intersection of sets. Commutative, that is A intersection B, then B is intersection A for any two sets A and B. intersection of sets is associative, which is if A intersection B intersection C, then A intersection B intersection C. We can make brackets and write it like this. If A is a subset of B, then A intersection B is equals to A. Here it was A. If A is a subset of B, then A union B is B. Here it is, if A is a subset of B, then A union B is equals to, because A has the elements of B, and here A intersection B is which are the common elements in A and B. So that is why it is equal to A. Similarly, A is a subset of universal set, then A intersection universal set will also be A. Same method, okay, same property. For any sets A and B, we have A intersection B is a subset of A, and A intersection B is a subset of B because both have common elements. A intersection empty set is equals to empty set for every set of A. Okay. Now difference of set. For any two sets A and B, the difference A minus B of all those elements of A which are not in B. So A minus B will be A such that X belongs to A and X doesn't belongs to B. Okay. The elements which is in A minus B. Okay. So which can also be A is a subset of B, or A minus B is an empty set. And clearly A minus B is not equal to B minus A. Okay. Like 5 minus 3 is not equal to 3 minus 5. It is same like that. Complement of a set. Let universal set be the universal set, and let A union, sorry, A is a subset of universal set. Then the complement of A. Then the complement of A, which is denoted as like this, A and a slash, okay, in the set of all those elements of universal set which are not in set A. So let universal set be 5, 6, 7, 8, 9, 10, 11 and A be 5, 7, 11. So your complement of set A will be all those elements in set universal and which is not in set A. So that will be A universal minus A. So it will be 6, 8, 9 and 10. Remaining, only the remaining elements of universal set which is not in A. Okay, like in intersection was common. Here it is the remaining which is not common. Okay, and some results on complement is empty set. Complement of empty set is universal, is equals to universal, and universal complement is equals to empty set. A union A complement is equals to universal. A intersection A complement is empty. Okay. Now distributive laws for union and intersection of sets. A union B intersection C is equals to A union B intersection A union C, because this is common for both of this. We can multiply this with this and this with this. Okay. So this is like this. A intersection B union C will be again same. A intersection B union A intersection C. Okay. And these are few De Morgan's law. When A union B, the whole complement is equals to A complement intersection B complement. This is the law. Okay, we can't change it. Ulta it will become while removing the bracket. Similarly here also, A intersection B complement is equals to A complement union B complement. Okay. I'll explain this exercise in the other video. I hope you all understood the sets and the laws. Do like, share my video and subscribe my channel. Thank you. Bye.